I'm gonna tweet out that I'm streaming from the NH collection in case anyone wants to come by and say hello. What? Ain't no way.
It's kind of like they also put like cinnamon. Yeah.
I think I'm sick to my stomach.
You had to let them know that you're delayed.
No, I mean, I kind of like it's funny, and it's like part of the comedic thing for the workshop. But like that is definitely a blocker. Yeah.
I guess it's going to be your room. Yeah, because it's his room.
No, but my room is too small.
Really? Yeah. You were in there. Oh, it was fine. Like creation.
We could just go to that table. Yeah, why not just go to that table? All right. Y'all go against the wall so that. Okay. I know. I wish I brought. Okay.
The thing is, choose something that doesn't get way on the Like, this is only the one. My daughter watched it. This is the first time I'm wearing it.
Oh my god. That is funny. Yeah.
As soon as you go down, there's like something you
Yeah. Right. Oh, there's charger. Thank God. Oh shoot. All right. Oh, it doesn't. I don't think it works though. I mean, it's fine. Like it's. Yeah.
That's what she said.
All right. Um. So yeah, I'm gonna be. Oh, Flo retweeted it that we're here. That's funny. That's really funny. So I'm gonna be monitoring the Discord chat on my phone because I'm not gonna be on Discord here. Um, and I'm also just someone mind monitoring the YouTube chat because people might be there since I'm only there. Um, All right, I think this audio is working. All right. Yeah, you can do that. Okay, so if anyone is watching this right now, then actually, if you can hear this right now, then type in the Discord chat. That picture's really funny. Yeah, at the piano. I wonder what the delay is like between YouTube and dox. Becca says doxing myself in the YouTube chat. Oops. Yep, you would do that. What?
is like a pseudonym.
Oh, I don't know. Becca BZ is asking if Becca is a pseudonym. Okay, people can hear. Okay, cool. All right. I've come to the conclusion that Macs need to like become better. Like it's actually crazy that just streaming on a Mac can like crash the whole computer. You know? Oh no, Mac stock is the best. Yeah.
He's like really good when it's talking
Yeah,
about.
he's the best.
Yeah, my Mac is like nine. But how old is your Mac?
Like 3 years, I think.
Oh, yeah.
Yeah.
It's mine 3 years as well. Videos like.
Oh, is it really? Yeah. Okay. I wonder how I could fix that. I don't think I can. Probably not, right? Maybe it's worth just turning it off.
Video?
Yeah.
Maybe or you can start with an intern, but
Okay. Yeah.
just people can see the videos.
Of course. Yeah. Okay, so it's 4 o'clock. So we're gonna get started in like what? Oh. I thought you were gonna. I thought you were gonna say something. All right. So yeah, it's 4 o'clock. We'll get started in a couple minutes here. Um. Yeah, I know the video is a bit laggy, but okay. Yeah. I'm just gonna turn it off. I'm just gonna sit up a little bit as well. Like I says, I tried to streaming League on my Mac, and that was a no go. Yeah, I used to do that back in the day too, but I decided I couldn't do it anymore. Okay, so it's 4:02. I think I'm gonna get started. So I turned my video off on OBS because I know it's lagging super bad. I wish I could show you, the setting around here, but basically I'm in some hotel right now, and I'm joined by Andrea. So Andrea's here, and BZ, Sweet, and Willie Blue are all here with me to share this workshop. And they're gonna be clapping in the background and they're saying woohoo. So yeah, if you want to see, or if you have any questions for them, let me know, and we'll turn this into a bit of like a live AMA. Um, but yeah, so what are we going to be teaching today? I actually forgot already. So we're going to be teaching account storage. So chapter 4, day 1. Now I know there's also like a bit of lag between the YouTube stream and the IRL and like what you're actually like seeing. So if you have a question, like don't be afraid to put it in the chat, and I'll answer it as soon as I can. Once even though there's a bit of a delay. Okay. So yeah, we're gonna be talking about account storage. So account storage is super important to flow and cadence, what we've been talking about over the past couple workshops. And it's basically like an area of cadence that like really makes it like different from things like Solidity and Ethereum. Um, so you know on a, we talked about before, we're on the Ethereum side, when you have like an NFT, what happens is that NFT gets stored inside the smart contract. And so it doesn't represent true ownership because, you don't actually, truly own your NFT. It's stored inside the contract. This is different on Flow, however, because, you actually store things inside of your own account. And goes way back to when, the Flow and Dapper team decided to make the Flow blockchain after they had struggles with CryptoKitties because they didn't like the CryptoKitties stored NFTs inside the contract, and they actually preferred to have it, in your own account like you do on Cadence. So we're going to be talking about what account storage is and how you can actually store things inside your account. And what this includes is, for example, all the NFTs that you own on the Flow blockchain, they're all stored inside of your account. So your goats, your Flovatars, everything you have is stored inside what's called account storage. And so we're going to learn how to code that today. So before we do that, let's go over like what actually lives inside of an account. Well, if you look at this diagram, there's like this red box, right? And this is like the account. This is your whole account on the Flow blockchain. So remember before when we went to, we were looking at the Flow playground, these are all addresses, right? So like 0x1, 0x02, 0x03, these are addresses, but they represent accounts. And so tab close is good now. Okay, perfect. Yeah, so that represents accounts, and inside those accounts, they store something, and that's namely these right here, the green and blue boxes. So one thing you store inside of an account is the contract code, right? So for example, in account or in address one right here, when we deploy the contract, that gets stored inside of address one or account one, and so that is this green box right here, right? The contract. Whereas account storage is a little different because with account storage, you have these 3 different areas of storage. One is called storage, one's called public, and one's called private. We're going to talk about public later, and we're going to leave private for a much later time. But we're going to mainly focus on this orange box right here, this storage path. This is where all of your data actually lives. So again, when you have your address and you interact with, let's say you have Blockdo or something like that, and you go to purchase NFTs, you're actually purchasing NFTs and they're getting deposited into this storage box right here. This is where all your stored data lives. And if you wanted to, you could also deploy a contract to your account, and that would be in this green box up here. And I know that this visual stuff has helped Becca in the past, so I hope it's still helping. All right, so we're gonna dive into a bit of code now to see what this actually means. So inside of account one, we have this hello world contract, right? And so far that whenever we've had a resource, we always either destroy it, move it somewhere else, or we've like stored them in dictionaries, right? So this is a simple contract called hello world. Let me actually increase the fonts a little bit. And inside here, you have a dictionary that maps and UN64 to a test resource. We have the test resource right here. It's very simple. It just has an ID in it. And then we have this init function that just initializes the storage, very simply, okay? So in this contract, what you would do is, what we've learned so far is we would have a function called deposit, and, maybe it would take in a test resource like this, and then it would deposit it into the storage. So you would like self.storage at test.id, and you force move in the test resource, right? And this is one example of like what you would do with a resource. You would store it inside of the contract. But this gets a little boring, and the reason for this is because we haven't learned any other ways to actually, store our NFTs or our resources. So this is where we're going to move into the transaction. So throughout this bootcamp so far, actually, let me deploy this contract so we stop getting errors inside our transaction. But throughout this bootcamp, we've been talking a lot about this prepare phase and how we're actually going to leave that for a different time. Well, that time is now. So we're going to learn about what this prepare phase does and how this relates to account storage. So inside of this prepare phase, this is where we have access to an account's storage, okay? In this execute phase, you don't have access to it. In fact, this execute phase is simply just for executing some actions like we've done in the past. But the prepare phase is where we have access to account storage. Now, this brings up a topic of like, well, who has access to account storage? And the answer to that is only the owner does, right? Only the owner of an account should have access to their storage. Because you can imagine if that didn't exist, then I would be able to withdraw your NFTs, right? And that would be a really bad thing. Like I could just go in and I could access your account storage and withdraw your go, and that would be a really bad thing. So only the owner has the ability to manipulate someone's account storage. So how that happens is with a type called auth account. So just like a string or I spelled that wrong, a string or a UN64 or a boolean, right? An auth account is a type. And more specifically, it's a type that allows you to access everything about an account. So this is really interesting because with permissionless deployment coming, we talk a lot about like scams and stuff like that. That's going to come into play. And one thing that really scares me is the fact that if people are able to deploy their own contracts, they're going to take this account variable, which is an auth account type, pass that into the contract, and then withdraw all your NFTs, right? So that's one thing that could happen if that were the case. Okay, so knowing that, let me just make sure the audio. Okay, so it's still working. So knowing that, we have a bit of a problem, and we don't want to be able to pass this around. So you can only access this in the prepare phase, and that's why. But if you ever see a transaction where people are like passing this variable around, that's pretty bad because that means that they're probably going to try and hack your account. Okay, and we'll return to like security reasons in a bit. But yeah, looking at this prepare phase, so let's just go ahead and let's store something inside this account. So in order to do that, we need to have a function to actually like create this test resource. So let's go ahead and do that. Let's get rid of the storage. Let's get rid of this. We don't need either of these anymore. Let's get rid of the deposit function. And we're just going to make a function called create test that just returns a test resource. All right. And we're going to return create test back to the return value. And so now we can create test resources whenever we want. So let's go ahead and redeploy this contract. Boom, we did it. And so in our transaction, let's just go ahead and make a test resource. So let's say let test, it has type, test, and we're going to say hello world dot create test, just like that. This should be hello world dot test. All right. So instead of maybe storing this in the contract, let's try and store this inside of account storage. So the way that we do that is we say, account dot save, all right? And you have to pass in the value. So in this case, the value is going to be the test resource itself, and then you have to pass it a path. So what a path is if we go back to our diagram here, there's three paths, right? There's storage, public, and private. Now, when you're saving something to your account storage, you always use the storage path because that's where you store your your assets. So you would save this to /storage, and then you put another slash, and then you can name it whatever you want. So I'm going to name it my test resource. And when I do that, it's going to take this test resource right here. Right? It's going to create it. It's going to store it in the test resource. And then it's going to say, account.save. Account is the signer of this transaction. Pass in the test resource. and it's going to save it to /storage, which is where all your data is stored, and then my test resource. And again, this can be whatever you want, but you have to remember it for the future. All right, so if I go ahead and do this, let's send it. Oh, and by the way, this is where the transaction signers actually come into play, because now whoever signs this transaction is going to be the one that actually contains that resource. So if I were to sign this with account 1, then this auth account right here would be account 1. If I were to sign this with account 4, then this right here would be account 4. So when you think about think about floats, for example, where you claim a float. When you claim a float, we're giving you an NFT to your float collection. So when you click approve on Blockdo or on Dapper or Lilyco, your account is getting put right here, right? If you approve the transaction, your account is getting put here, and then we can save the the float to your account. Okay, cool. So let's go ahead and run this with account 1. And hope, okay, boom, so there are no errors. So if we were in like more of a live Discord format, I would ask you, which account has it now, but I'll just answer that myself. It's account 1 now has that resource. All right. I'm just going to check the chat to make sure there's no questions. Okay, seems all good. Cool. Yeah, so that is where the resource gets saved. Now let me actually, maybe it is smart to pull up the YouTube chat. Okay. All right, cool. So so we save it to the account storage right here. All right. Now what we can do is let's try and figure out what resource is actually stored at this path. And if we go back to our our example, let's see. So we already went through the save function, right? So save right here, and notice that in the chapter we actually use signer. So I don't you can name this whatever you want. It doesn't have to be account. You can name this signer if we want to, because they're the signer of the transaction. But if we put signer there, then signer.save and then the resource, okay? But one thing I want to note also before we actually read the resource that's in our storage now is only one thing can exist at a path at a time. So if we try and sign this with account 1 again, let's send it, right? Well, that shouldn't have happened. I don't think the playground's being buggy. Okay, yes, there you go. So you see that I tried to run this transaction again, and it says failed to save the object. At this path, right, in account 1, it already stores an object. So remember back when we learned about resources, we talked about how you can't ever overwrite a resource. And this is really important because if we were able to save something to this path, it would overwrite the other resource that currently exists there, and that's really bad. So for each resource, you can only have one storage path. So again, if we run this again, it wouldn't work. But if we were to run this with account 2, it would work because that account has nothing there. So you'll see we run it with account 2 and there's no errors. But again, if we run it a second time, then there's a problem. All right, so just so that you're aware of that. All right, let's name this save test, just like that. Now let's open another transaction and let's call this load test. So this transaction is going to load or bring something out of storage. So if we go ahead and copy this transaction, let's go ahead and paste it here. And instead of saving it, let's say let test, which is a hello world or test resource. And let's move in signer.load /storage /my test resource. I think the playground's being buggy again. I believe so. The playground. Oh, no, it says put the type. Okay, it says put the type here. So look at that. I forgot my own thing. So when you load something out of account storage, so we bring it out, you have to put the type of what that variable is. So in this case, we know it's a hello world test resource type. And what we can do is, we have to unwrap it as well because it's coming out of account storage and say, or nothing exists here. So what's going to happen is we're going to go into our account storage, right? Signer.load, it's going to go into the account storage. And the thing that we're loading is a hello world.test resource, right? That's the type. And we put those in between these little brackets right here. This is new notation for all of you. So in this notation, we put the type of the resource, and then we say it's coming from, like where are we withdrawing it from, /storage/my test resource, like this. And if nothing exists there at that path, then we can panic and say nothing exists here, okay? And so that, yeah, so that, it'll just panic and abort the whole program if that's the case. And then what I want to do after is I want to log test.id because the resource has an ID, and then we're just going to destroy it right after. All right, so let's go ahead and run this for account one. Let's clear this, run it for account one. I don't think I did that right. Okay, so let's send it again. Weird. I feel like I'm doing this wrong. I think the playground's being weird again. Yeah, okay, the playground's just being buggy. So, yeah, so I don't think that was, okay, so anyway, I just feel like refresh the page and it's fine again. But you'll see that it logged ones. This is the ID of the resource. Now, again, if we were in a live format, I would ask you, well, what is, if we were to run this again from account one, what would happen? Well, the answer is that it would panic. It's just nothing exists here. And the reason for that is because we just withdrew the resource from storage, right? So it no longer exists there and we destroyed it. So if we were to run this again, it would say nothing exists here because we just withdrew it. All right, so let's go back to save test. Now we're in save test again. So if we run it with account one and store it, okay, so now something does exist there. And if we were to go load it again, now if we click send, it logs 3. And then if we log in again, or try again, it says nothing exists, okay? So only one thing ever exists there at a time. Cool. So that is both, that is both save and load. Any questions about that? And if you have a question, just feel free to ask in either the YouTube or Discord chat. All right. So I think people are okay. Let me check YouTube again. All right. I hate this doesn't work. Okay, cool. So let's try and borrow now. So inside of our transactions, let's make another transaction. This is borrow test. And so now that we're borrowing, like one thing that really stinks about loading is that if we want to, read some information about our resource, we would have to save it to our account storage. And then we would have to, load it out of account storage, read data, and then save it back, right? And that really stinks because you have to do a lot of moving all the time. So what we're going to try and do instead is we're going to try and borrow a reference to the resource in storage. When we do that, we can actually keep the resource in storage, but still read information about it outside of it. So that's what we're going to do now. Let's make sure we have a resource in our account storage. Perfect. So we just saved one. And so now instead of loading it out and trying to read information, we're just going to simply borrow it. And we can do that however many times we want because we're not moving the resource anywhere. So to do that, it's actually a little different. We say signer.borrow, right? And now we're not borrowing the whole resource, we're borrowing a reference to the resource from storage, all right? Cool. And again, this is a reference, so a reference to hello world.test. And we don't use the move syntax either because we're just getting a reference. Cool. So what we can do is we can run this transaction, right, with account one to send it, and we're logging the ID, right? And if we run it again, it prints 4. And if we run it again, it prints 4. And that's because, again, we're not actually moving the resource anywhere. We're keeping it in storage and just reading a reference to it by what you call borrowing it. And then you can log information about it. So that is all there is for Chapter 4, Day 1 that's what save, load, and borrow do. And again, these are all using the storage path, which only the account owner can use. And in a second, we're going to talk about how the public can read from account storage as well. My stupid charger isn't working for the record, so if we black out for a second, then yeah, that's just GG's. Also, what I'm going to do for those of you listening is I'm going to upload both this recording and the recording from the last boot camp we did, so that you can have both in case the noise is too loud or something. So I'll give you all a minute to think about that, and if you have any questions, ask in the Discord or the YouTube, and I'll be here to help out. And also, BZ says he hates all of you. Okay. Yeah. So Becca, I'm gonna upload a recording from the last boot camp as well, since I know that this one's probably gonna be super laggy. But I'll just keep going just in case. Actually, I'm gonna keep going till my computer just dies. How about that? Okay. So now that we did this, let me see if this is still working. Okay. Okay, I'll just keep going. So my computer's like rapidly dying, but we'll try and figure it out. Okay, so now the problem is that with account storage, actually, let me see. Okay, so yeah, now the problem with it. Oh wait, I'm getting pings in Emerald City. Let me see if this is for. Oh, okay. Sorry. Yeah, I'm just trying to catch up on chat on both platforms. Okay, so now the problem that we want to think about is with this format, only people that own the account can actually read information about their resources in account storage. So, like I said before, you can't interact with the storage path unless you're the owner of the account. So, the question now becomes, if I am, a random person, right? If I'm a random person, how can I, read your NFTs? How can I read information about your NFTs without owning the account? And so that is where the public path comes in. So this public path right here. So we're going to move on to chapter 4, day 2. So Becca's asking BZ, why did you say that? Why did you say that about her?
Because I didn't know she was there.
Oh yeah, BZ says it's because he didn't know that you were here, Becca, listening. So he was trying to say it like behind your back. So I apologize. He's been super rude all day. All right. Anyways, so yeah, back to the example here, chapter 4, day 2. So this is the public path now. So this is available to. Enjai says, which hotel is that? I will never go there. It's the NH Collection. Yeah. We actually were recording in a different spot earlier, but then someone started playing the piano, so we had to move. Anyway, stop distracting me. Okay, so we're back to the chapter 4, day 2. Okay, so we're talking about the public path now. So this is where other people can read information about your account without having total ownership of the account itself. So the way that you do this is when you save something to your account. Oh, okay, yeah. So when you save something to your account, we're gonna do something called linking it to the public path. So let's take a look at our diagram really quickly. Yeah, so here's the diagram I want to show all of you. So this is, again, account storage, right? This blue box. And in this storage, there's 3 different areas. There's storage, public, and private. So storage is where all the data actually lives. So all your resources actually live inside storage. Now, the way that public and private work is that you use things called capabilities to actually point to the storage path. So what this means is, like, let's say you have an NFT in your storage path, you can say, you know what, I want the public to be able to read that. And so if the public can read that, then what you're doing is you're creating a link or a capability to that NFT in your storage path to be able to read it. Okay, so you have to explicitly allow the public to read it. So inside our transaction, when we save the resource to the account storage, we're going to say signer.link, right, .link. And inside the link, we're going to put the type of what we want the link to be. So a hello world .test, a reference to a hello world.test. And we're going to say this is the place we're going to link it to in the public is /public my test resource. And the target is where you're linking it from. Is /storage /my test resource. All right, cool. So what we've done is we've saved something to our storage path at my test resource. And then what we're doing is we're creating an arrow or a link, like I showed you in this diagram, from the public to the storage path, where we're saying /public my test resource is going to point to /storage /my test resource. And the type that we're going to expose is a hello world.test reference. All right, cool. So if we do this, let's just do this with like account 5, for example, because we know it doesn't have one already. Let's make one with account 5. And boom, it saved it, all right? So now what's cool is that we don't even have to run a transaction to read the data, because the only reason we were using transactions earlier is because we had access to the auth account. But when you link something to the public, you can use something called a public account to read the information, and you don't need transactions for that. You can actually use scripts. So we're going to use a script now. Also, my computer is like fully about to die. I might have to move. Oh, this one? Thank you. Thank you so much. Savior. You're a savior. Thank you. Oh, that's amazing. Okay. We got saved. Yes. Okay. I'm back. We just got saved by some heroes. Okay. So now BZ is staring me in the eyes while I do this. Do you have any words, BZ, for the audience here? He's winking at me. And do you have any words, BZ? Now he's laughing. Okay. So anyways, now that we're in a script, yeah, we're getting some behind the scenes pictures too. So now that we're in a script, we can actually use a public account to get this information instead of having to get the auth account from the transaction. So let's go ahead. Oh my God, BC is you are something else, BZ. So let's go ahead and get the public account. Now the way to do that is to say let test equals get. Actually, let's do this a different way. Let's say let public account equals get account, and then the account right here. So what this is going to do is this actually has a type of public account, just like this. So the way that you get a public account is unlike the auth account, where if you're inside of a transaction, it just gives it to you in the signer field. With the public account, you have to give it an address, right? This address right here, and it will fetch the account for you and get the public account type. And then once you do that, you can actually go into their public storage, right, their public path, and get information about what's in there. So you can say let let test equals public account dot get capability. So remember we talked about like linking. This link right here is actually a capability. So get capability to /public /my test resource, just like that, and then say dot borrow. So now we're going to actually borrow the type from the capability. And I know that a lot of this probably won't make sense at first. In fact, it definitely won't. But the only way to make sense of this stuff is to do it multiple times and to read through the course. So I know that I'm not pausing to explain what all this actually means, but I'm telling you the best way to learn this is to just watch this video again and again and to read through the course content, and you'll understand that it's a pattern over time. So then once you have the capability, you can borrow the actual reference from the capability. So think of this almost like as the bridge, and then borrow is like the actual borrowing of the reference, right, where you actually get the type. So we're going to borrow a hello world.test, right? And that's because when we saved it, what we linked to the public was we linked this type, a hello world.test reference, right? That's what we put up to the public path. So we're going to borrow the same thing, a hello world.test, and you put the parentheses there, and then we can panic if nothing exists there. So nothing exists here. All right. Now, once we're here, we can return test.id, and this is going to return a UN64. All right. So let's try this for like account 4. So with account 4, remember, we never saved anything to account 4, so it shouldn't work. All right, let's execute it, and it's thinking, and apparently the playground is so glitchy that it doesn't like if nothing exists there. So I guess it's just not going to work. So let's just refresh the page and hope that it'll work with the actual one that does exist. All right, so let's try it with account 5. All right, so we're trying it with account 5, and we know something exists there because we stored it earlier. So let's try it with account 5, and boom, there we go. So the return value is 5. Now, if we were to go ahead and save something to account 4, right? Let's save a test resource to account 4. Send that. Now let's go back to our script, and let's type in account 4. And if we execute this, then it returns 6, right? So now something exists there. So this is actually very similar to how it works when you like log into a DApp and it will display all your NFTs. It's actually going into your public account, getting the capability to your NFT collection, and borrowing like some type that allows you to read information about the NFTs, all right? And then it's, returning it back to the script. All right. All right. So how's everyone doing? Everyone doing all right? And again, I'm gonna upload the recording from the last Academy too. All right. Cool. So what we're gonna dive into next is, and this is sort of like the last part of the workshop. So we're actually going pretty fast here. I was probably speeding up because my computer was dying. Um, but what we're going to talk about now is how do you restrict certain behaviors to the public without exposing everything. So the problem with what we've done right now is, let's say that inside of our resource, we have a public function called change ID. I don't know, something random. Right? It's a public function change ID. And inside here, we're going to allow only the owner of the resource to change the ID. So we're going to say self.id equals 10, okay? I don't know why, just making it that, right? So again, we only want the owner to be able to change the ID of the resource. So if we deploy this contract, then there's going to be a problem. Because right now, we're saving the resource to account storage at /storage/my test resource. And then we're linking to the public hello world.test. Now, as you all know, right, we've learned a lot about, resources. This reference will allow you to call change ID, which is a big problem, right? So, and obviously that's not good. So if we were to run this transaction with account 1, right, now we store a reference. And so inside our script, what we could do is we could, when we borrow the reference from the public, we could say like test.change ID. And this is really bad. And now again, this is in a script. So like in a real world scenario, this would never actually change the ID anyway. But you can imagine that you would change a transaction inside the, is this related to why it is not possible currently for Emerald.find to not access this later? So Tabcole, the reason that oh no, we have some people laughing. I wonder what they're doing. I don't know. But so Tabco, the reason why Rarible is so trash is because they don't correctly link your collection to the public. So it doesn't allow services like Emerald and .find to read information about people's NFTs because they don't link it correctly. Yep. So that's actually why, and we're gonna go into actually that a little bit more later in the bootcamp. All right. Cool. So again, this isn't good because this. What is going on here? Oh, they already made the float. Oh my god. So yeah, so what this isn't good because let's say that I stored a resource in my storage, and then BZ came in and was like, you know what, Jacob, I want to hack your account, which he tries to do pretty much every day, and he went to borrow my resource inside in a transaction and change the ID. That's really terrible, right? So we don't want that to happen. So how do we fix this? Well, we can fix this with resource interfaces, and this is something that we talked about during the last workshop. So we can say public resource interface iTest. And inside iTest, we're only going to expose the ID. We're not going to expose the change ID function. So remember we talked about, resource interfaces are really good at only exposing certain behaviors to the public. This is one of them, right? So if what we do is if we add iTest to the test resource, now let's redeploy this contract. And so when we link this to the public, we're only going to link hello world.test restricted to, remember the restricted to thing we learned about in the resource interfaces section, restricted to hello world.itest. Just like that. So now the public only has access to hello world.itest. Okay? And if you remember correctly, hello world.itest is restricted to only the ID. So let's send this now. All right, account one stores the NFT. And now in the script, look what happens. So we now have to change our borrow to the correct type, because if we tried to borrow this right now, it wouldn't work because this type is not exposed to the public. So this would panic. What is exposed is hello world.test restricted to hello world.itest. All right. And now look what happens. Now we can no longer call change ID. So this is how we protect our resources. And when we go into future lessons, we're going to talk a lot about NFT collections. And if you think about like an NFT collection, an NFT collection has a deposit function, it has a withdraw function, right? All those things. And some of those, namely the withdraw function, we don't want to expose to the public. So what we do is we make a resource interface where you can only call like getting the NFTs in there or depositing, but you can't call withdraw, right? So I hope that this helps you understand that when you're on platforms like Goated Goats or a lot of those other platforms, when they have you initialize your collection, this is exactly what's going on. It's having you initialize a resource that's a collection in your account storage that allows you to deposit, withdraw, but they have to link things to the public, like linking the deposit function to the public, but not the withdraw function. And so Tabco, back to your original question, things like Rarible do this really poorly. And they could have just asked me to do it, but they did it really terribly, and so they messed it up. And it is what it is now. And so everyone's collection is now incorrectly linked to the public, and it doesn't allow services like Find or Emerald to get information about people's NFTs. Okay. So BZ, anything to say?
Remember the float.
BZ says remember the float, so he's making a float.
I'm not making the float. You're making the float.
Oh, I have to make the float?
Oh, give me your phone. I can make it.
So what do you have on your phone?
I'm being ready.
He's sleeping.
No, but there's an event here.
Yeah, your event.
That's your events, man.
Yeah, but it says under your events you have. Oh, okay. Wait. So you started. Oh, I guess it's glitched.
He's looking at your profile.
I'm looking at your profile.
Oh, that's my profile. Oh, I see.
Why would I look at my
Okay, yeah, yes. All right. So Willie Blue or Sweet, anything to say? So Sweet says, let me see what Sweet has to say.
Sweet says Jacob is a noob. Yes.
Yeah, Sweet just said that, and that's so mean.
Yeah.
Thank you. Yes, so rude by Sweet. Becca says, yeah. Okay.